Hey, how's it going? So I'm still working on this baseball game here, and this baseball game has a pitcher that is throwing a ball, right? And right now we're controlling the pitcher who's throwing the ball, but we'd really rather be controlling the batter and having the computer control the pitcher, all right? Because all the pitcher does is throw the ball; it doesn't really do very much, and the batter that can at least test your reflexes. So we're going to move towards controlling the batter rather than the pitcher. All right. So if we do that, we're going to need a batter, and we're going to need to sort of randomize the pitcher. And at some point after that, I'm going to have to actually draw the batter and animate him the same way that we've animated this guy. And then after we've done that, we'll start doing some two-dimensional stuff. So right now, it's hard to tell because it probably won't drop that much when we actually run put the physics in. But there is no gravity here yet. We haven't added any gravity to this ball. It doesn't drop at all. Everything's linear, all right? And that's the way I teach this class, right, is just to do things that go in a straight line first. And after you got the straight line stuff, then we can try to do things with multiple forces and multiple directions and things like that. So we're in a pretty good spot right now. So what I want to do is, in this particular case, what I want to do is I want to institute a batter here. So I'm just going to make a little rectangle. And when the ball gets to that little rectangle that's centered on home plate, what I want is for the ball to reflect off of that rectangle. All right, so it'll just bounce off and go straight back towards the pitcher. Not anything excessively complicated. That will get us through some simple stuff, and we can use that and build off of that when we want to make a more realistic hitting algorithm, right? So, but first we just want to bounce the ball off of a rectangle, right? And after we bounce the ball off the rectangle, then we'll come in here and we'll modify the pitcher, and if we haven't, so that the pitcher will throw at random times, and maybe we'll modify the rectangle so that you have to press a space bar or something when the pitch is close enough so that it can, when the pitch is inside the rectangle, for it to reflect. So some, a little tiny bit of control and stuff like that. So that would probably be the next two videos. Okay, so this one will just make the little rectangle that reflects off. Next time we'll refactor to play the batter, which will be a rectangle instead of the pitcher. All right, so that seems to be a pretty good idea to me. So that means that first off we have to make that rectangle. Now the rectangle is going to be another object, or I shouldn't say the rectangle, the batter is going to be another object, and so we have to figure out how we're going to tell the computer how to use that object, right? So we're going to have to make a class, right? A class for a batter. And we can either use this class here for ball as a template, or we can use pitcher. Which one do you think is more like a batter? Probably a pitcher, right? Now we could be even more formal about this and do something called inheritance, but that comes later in the class, and that might even require even more refactoring of the pitcher, right? So we'll just add in the things that we need to add in. So first of all, we're going to start with a batter. He doesn't need to do all this other stuff. He doesn't need frame time. He doesn't need reset right now, because all he's going to do is be a big rectangle in the middle of the screen, right? So all we need is a position and a height, and later on we can add in whatever other stuff we need. So the position is one X component and one Y component that we'll save individually, and then we'll have a self height equals self h, which is the height of the batter, right? And we need some way to draw it. Self first. We draw ourselves, or the batter draws itself on the screen to the correct scale. And that scale, this scaling factor goes again from feet 2 pixels, because the screen doesn't draw in feet, it draws in pixels. You don't have a 6-foot screen to begin with, so. And offset, and that just tells us where the field is drawn compared to the entire whatever that thing is, where the field is drawn compared to the actual window. So we could have all sorts of wingdings and things all over the place, and just have a third of the screen or 2/3 of the screen be the field, and this would let us choose where to put that field. So that's just where that stuff goes in. Now we're going to draw a rectangle, I said, so that uses PG Draw Rect, and that we draw on a screen. It needs a color, and we have orange for one guy, we'll use yellow for the other. That requires 2 sets of numbers in here. The first set is the upper left-hand corner, the position of the upper left-hand corner of the guy. I'll call those X0 and Y0. And then it's the width and the height of the rectangle from that. So that width is how far to the right, or I guess how far to the right, and height is how far down to draw the rectangle. And then we need a width. We don't need a width. We could have a big yellow rectangle, or I can have a yellow rectangle, or I can have a yellow box. I'll do a rectangle and have that too there, which just says how thick the line should be. So now we need to draw all of these different things. Let's see. The first thing, I guess, is the width. And that is, well, let's start with the height. H is going to be the integer part of self.h, because this needs a integer. Self.h and the scale are should both be floating point numbers, hopefully. And the draw only takes integers. Now we use the floating point numbers because it's a little more accurate, and we don't want it. We want as few sort of truncation errors as possible. And the width is going to be some fraction of that. So normally that's about 1/3 from the tip to your shoulder, from 1/3 from your shoulder to your shoulder, and 1/3 from the tip of your arm to your shoulder again. So that's about 1/3 of your total height. It's only an estimate, and if it's too skinny, we can change it. But that's an estimate of your body size. And let's see. Now we need X0 and Y0. I'm going to start with X and Y. And why am I going to start with X and Y? Well, first I'm just going to find the position of the center of the guy, which is what self X is, and then we multiply by screen or scale, and add in the offset. Once you make an error, you keep making that error for the rest of the day. Plus offset, and remember the 0 means X and the 1 means Y. So now this is the center of the box. Right? We keep track of the center of an object in this class, just because that's what we do in physics. That center of the object is the most important part, and when we're drawing it, we can convert to whatever we need to do. And that's what I'm going to do now, right? So X0, right, is going to equal X, the integer part of X, minus whatever we need to do to get up to that upper left-hand corner from his center, right? That upper left-hand corner doesn't have any real meaning, right? It's not part of the guy at all. It's just where I want to draw this box around the guy. So, and later on it'll be where we want to start drawing the picture from. So if we have an actual image that we want to use for the batter, we're going to have a little clip of it, and we're going to draw from that upper left-hand corner as well. So it is important to know how to do this. So we subtract from that the height, and we could do it either just use the previous thing, or we could use this. And I'm going to use this just because I don't like that rounding error idea, although it might have no effect at all. But my experience is it usually does. Okay, so now we've got the batter. We've got a little bit of the batter. We've got the initialization part and the draw part. That should be enough to get him going. We have one or two more things. I think just one more thing to actually get this part going. Let's see. So now I need to create the guy. All right, so the batter is going to be, the batter object is going to be some member of the batter class with a position and a height. I'm going to go ahead and keep using 6 feet for the height, but I'm going to rename I'm going to change the values of position. Remember when we made position, we had 60.5 feet between the home plate and the pitcher's mound, and 3 feet for the distance from home plate to the edge of the screen, which is half the batter's box. So we'll just put that 3.0 feet there. And since we're drawing this guy sort of relative to the bottom, we're going to start with field size minus field size 1, the total height of the screen, and then we're going to subtract however much of him that we need to get to the center of the guy, which is height over 2. Okay, so then I'm going to need some way to get him this guy into the update function and the view function. And the easiest way to do that, since we're already sending this other stuff to update and view, is just to put batter in there. And then even if there's no ball, it will send something to engine and view. So let's see what we do. We've got that guy, and he's way up in the corner. Wonderful. So let's see. So let's see it again. Oh, okay. So, all right. The issue here is I should have divided by 2 on here. So because it's half his height, we move up. Okay. So now we've got a batter sitting there, ready to do stuff, but he's unhappy because you see here it says it has no attribute update. That's because in the engine way down here, in the engine, he's getting passed into objects here, and everything that's an object has to update, and he has no update method. So every object is going to need an update method in all of your physics stuff, and really just needs itself and the interval for the update. You don't have to send it anything else. And we don't want to do anything with this guy yet, so if we run it now, it blows up. Oh, something needs a get position. All right. I don't think it really needs this. This might be something. Well, we are going to need it in a moment, but okay. See, so now I throw it, and bam, I can see that the ball's going towards him. That's about what I have time for. I guess I'll have to add in all the other stuff later. So let me see what I can get done with the reflections and stuff like that, and then we'll come back to the picture.